Hello class, this is a continuation of logarithms. In this video we'll be looking at further log evaluating without a calculator using log laws. So we currently know the relationship between logarithms and exponents. So a to the power of n equals k can be converted to, using logarithms, log base a of k is equal to n. Or as you've seen in the previous video, this one here that I like to remember, 2 cubed equals 8 becomes log base 2 of 8 equals 3. We also, well, I hope we currently remember the 4 basic logarithm laws. And here are some further logarithm laws that we'll learn to use for further evaluating. So the fifth one, logs of the same base. So remember, they have to be the same base. If you add 2 logarithms of the same base, it's the same as log base a of the product of those 2 results. Similarly, if you have a logarithm, 2 logarithms of the same base, and you take the difference between the 2, it's the same as log of the same base x divided by y. Okay, so the order is very important. As a point of comparison, a lot of people do this wrong, so this is wrong. They get confused with log a of y over x. That is incorrect. That's a common mistake that I've seen before. And lastly, if we have log base a of any number to some other power, it's the same as moving that power as the coefficient of the whole thing. This one's a little bit more confusing. I'll do an example here. Let's say we had log base 2 of, let's not use that, of 5 to the power of x. Now remember, it's 5 that has the power. Okay, so x, this becomes x on the outside, log base 2 of 5. Hopefully that clears it up for you. And now, as a result of this, if you have a logarithm of a denominator thing here, this is the same as x to the power of negative n, and that negative n acts the exact same way here, but now it's a negative n log base a of x. Let's do an example of that here. So let's say I had log base 2 of 1 over x squared. This is the same as log base 2 of x to the power of negative 2. And this becomes negative 2 log 2 of x. Okay, so I hope you see the comparison between the two. So now let's use these logarithm laws, right? And these ones here will be later used to solve exponential equations far better. So let's get straight to some examples here. So given log base 2 of 3 is equal to 0.68 and log base 5 of 4 is equal to 0.86, let's evaluate these numbers here. Okay, well, we don't know what log base 5 of 12 is, but we do know that this is the same as log of 5, and this is 3 times 4. And we saw that because these are the product, let's go back up here, because they're the product, we can go backward as well. So since it's 3 times 4, this can become log 5 of 3 plus log base 5 of 4. In which case we can evaluate this. This is 0.68 plus log base 5 of 4 is 0.86. And adding these two together, this becomes, going from right to left here, 4, 9, 5, 1.54. In a similar way here, we have log of 5 of 0.75. 0.75 is 3/4. This is log 5 of 3 over 4. You can probably guess that we're going to be using this one here. Notice how it's x over y, or in this case 3 over 4. And we can go backwards using the same log laws. So log base 5 of 3/4 is the same as log base 5 of 3 minus log base 5 of 4. But we know these answers. This is going to be 0.68 minus 0.86. And I believe this is going to be 8 minus 6 is 2. 6 minus 8. 8 minus 6 is 2. 6 minus 8 is negative 2. So 2, negative 0.22. I apologize if that's wrong. I'm trying to do this without a calculator. Here we go. Log base 5 of 9. Well, I know that this is log base 5 of 3 squared. And because we know that to be 3 squared, we can move that power as a coefficient of the whole thing. So notice how we can move that power of 2 to the front. So 2 log base 5 of 3, which is 2 times 0.68, which is equal to 1.2, 0.8 times 2.36. One last one here. This is log base 5. This one we can change to become 5 times 4, which we can simplify to log 5 of 5 plus log of 5 4. Hope you remember from the previous logarithm laws, this is equal to 1 plus, and this we know the value of 0.86, which is equal to 1.86. My screen's freezing up. Let me go back and forth. All right, so let's solve now for x in this example here. So this is not related to the previous one. In this case, log base 2 of 3 plus log base 2 of x should equal log base 2 of 12. Well, using our log laws, because it's the sum of two logs of the same base, we can actually make this become log of 2, 3x is equal to log of 2, 12. Now you can just see from observation, 3x and 12 should be the same. So 3x should equal 12. X should be 4. We've solved for x. All right, let's do an example here of a log scale. The Richter scale measures strength of earthquakes by measuring the intensity and the regular signal of an earthquake by the formula R is equal to log of I over S. And I'm guessing that I is the intensity and S is the signal of the earthquake. show that log I equals r plus log s. So pretty much what it's saying is, how can we rearrange this original equation to become something like this? Well, let's write this above. Here we go. Oh, sorry, below. R is equal to log of I over s. We can rearrange this because it's the division of two logs here. This is log of I minus log of s. We can add logs, so I'm going to do plus log of s on both sides, so plus log of s. The left hand side becomes r plus log of s is equal to the log of I. As you can see, it's just a rearrangement of this. Let's make this nice and neat. Log of I is equal to r plus log s. And there we have it. Show that I is equal to s times 10 to the power of r. Okay, so here's where it gets a little bit tricky. I hope you've read this one here. If a base of a log is unspecified, it's assumed to be log base 10 of whatever. So in this case, this is log base 10. So let's write this here. So r is equal to log base 10 of I over s. So using our very original definition of logarithms, so a to the power of n equals k, becomes log base 10, oh, not 10, log base a of k is equal to n. Using this definition, we can rearrange this one. So the base becomes that one there, so 10, so equals n, so in this case equals r, becomes the power, so it's going to be 10 r equals I over s. I over s, multiplying both sides by s, gives us s times 10 to the power of r equals I, which is just a rearranged version of what we wanted. So hope that gave you more insight into utilizing the log laws. Hope to see you in the next video. Best of luck.